So today we're going to be going back and talking about factoring again. I know that's something that's kind of challenging to remember all the rules and all the different ways to do that. So we're going to look at a couple of methods this week and then a couple of more methods of factoring next week. So the first method we're going to start off with is factoring using the greatest common factor. So we can factor using the greatest common factor. And the easiest way to explain this is by using an example. So if we had the function or the expression 3x squared plus 6x, and we wanted to factor this using the greatest common factor, then we're trying to figure out what is the largest factor that goes into both of these terms. So what divides 3x squared and 6x? So we're going to look for the largest number that 3 and 6 are both divisible by, and we're going to look for how many variables we could factor out. So starting with the numbers 3 and 6, both 3 and 6 are divisible by 3, and that's the largest number they're both divisible by. So we're going to factor out a 3, and then we look at the variables as well. So we have an x squared and an x, and we want to factor out as many variables as we can. So as many x's as possible. So we have x squared, which is 2 x's, and x, which is just a single x. So since this one only has the single x, we can only factor out the 1x. So we can factor out an x, and then we put our parentheses, showing that we factored this out. And then inside our parentheses, we're going to write whatever we have left after we divide both of these terms by 3x. So when we factor out the 3x from 3x squared, 3 divided by 3 would give us 1. So we could write the 1. We don't have to write a 1, but we can. And then x squared divided by x, well, we took away a single x. We had 2 to start off with, so we have an x left over. So 1x for our first term, and then our second term, 6 divided by 3 is 2, so plus 2, and then x divided by x would divide out, so we wouldn't have any variables for our second term. And then I'm going to rewrite this without the 1 because we normally don't write a 1 as our coefficient, so we would have 3x times x plus 2. So that's factoring using the greatest common factor. Let's go ahead and look at a second example. So let's look at the problem 4x to the 5th minus 16x to the 4th plus 6x squared. All right, so we want to try and factor this expression using the greatest common factor. So we need to look at the largest number that all of these numbers are divisible by, and then we also want to look and see how many x's we could take out from each term. And we have to take out the same number from each term. So starting with our numbers, we have a 4, a 16, and a 6. So 4 and 16 have several factors in common, but 6 makes us have to pick some more specific factors. So if we start with 1, all of these are divisible by 1, but dividing by 1 wouldn't change anything. Next, we go to 2. All of these numbers are divisible by 2 as well. They're all even, so 2 would work. If we move up, 6 is divisible by 3, but 4 and 16 are not. 4 and 16 are divisible by 4, but 6 is not. So we've reached the point where we're not getting any more common factors. If we keep going up, none of them are divisible by 5. 6 is divisible by 6, but 4 and 16 are not. And so we've run out of factors at this point. We could keep trying to go up and count it by numbers, but we only found one factor in common. All of these numbers are divisible by 2. So we're going to factor out a 2. Next, we look at our variables. We've got an x to the 5th, x to the 4th, and x squared. So we want to take out as many x's as we can. So we're looking for the power of x that we could factor out. So we've got x to the 5th here, to the 4th, and x squared. So we can always factor out that lowest power of x from every single term. So we're going to factor out x squared. So then we go through and actually do the division now. So starting here, 4 divided by 2 would give us a 2. And then when we do x to the 5th divided by x squared, we started with 5 x's, x times itself 5 times. We took out 2 of those, So if we take out 2, we would be left with 3. So we have x cubed left over. Minus 16 divided by 2 is 8. And then if we had x to the 4th to start off with, and we took out x squared, we would have 2x's left over for x squared. And then finally, 6 divided by 2 is 3, so plus 3. And then x squared divided by x squared, well, anything divided by itself would be 1, so it factors out completely, leaving us with just the 3. So there would be no variable for our last term. So we get 2x squared times 2x cubed minus 8x squared plus 3. All right, so that was using the method of factoring by the greatest common factor. And that's what we can use for any expression as long as they have a factor in common. And then the next method we're going to look at is going to be the difference of squares method. And that's going to be the only other method we look at for today. So the difference of squares method can be used when we have two things that are perfect squares. So to start off with, the rule is if I have a squared minus b squared, then to factor this would factor into a plus b times a minus b. Now, that doesn't really help us make a lot of sense of what we're doing, so let's look at it as an expression. So if we had the expression x squared minus 4, this is going to be the difference of squares because both of these terms are perfect squares. X squared is x times x, so that's a perfect square, and 4 is 2 times 2, so this is a perfect square. So when we factor this using our difference of squares, we take the square root of each term and then write it in this form. So the square root of x squared would be just x, and the square root of 4 is 2. So x plus 2 for the first part, and then for the second part, we would do x minus 2. So notice whatever was here that was squared, we took the square root and wrote it here. And whatever was here that was squared, we took the square root and wrote it here. So let's look at another example. Let's say we had x to the 4th minus 16. All right, so x to the 4th is still a perfect square. X to the 4th is x squared times x squared, so it still works here. And then 16 is a perfect square. 16 is 4 times 4. So when we write it in this form, in our factored form, we take the square root of x to the 4th, and when we take the square root of x to the 4th, we get x squared, so x squared. And then we take the square root of 16, which is 4, and we write x squared plus 4 for the first term, or for the first factor. And for our second factor, we write x squared minus 4. Now, when we get to this point, we're going to check again and see if we can factor anything else, because I noticed that we've got something here that looks like what we just did up here. So I'm going to factor this again. X squared plus 4 I can't do anything with, even though both of these are perfect squares. This rule only works when we're taking the difference. So there has to be a subtraction sign here for us to be able to use the difference of squares. So x squared plus 4 has to stay the same. We cannot factor that using this method. But x squared minus 4 we can factor using our difference of squares method. In fact, we can do that by using exactly what we did up here already. We would get x plus 2 times x minus 2. And so this right here would be the factored form of x to the 4th minus 16. I'm going to show you one more example of what you can do when there's a number in front of your first term. So say you had, let me think of a perfect square. Say you had 25x squared minus 9. All right, so a little more complicated because now we have this number in front of our x squared, but we still want to try and use this difference of squares method because we're subtracting, and we know 9 is a perfect square. 25 looks like a perfect square, and x squared is a perfect square. So we're going to use the same difference of squares method, and we still follow that same pattern. We take the square root of each term and then write them together, one with a plus, the other with a minus in between. So if we start with the 25x squared, the square root of 25 is 5. So we write that. The square root of x squared is x. And the square root of 9 is 3. And we put a plus in between them for the first factor. For our second factor, we write the same thing, but with a minus in between. So 5x minus 3. And so this would be the factored form of 25x squared minus 9. All right, you guys, so that was 2 methods of factoring using the greatest common factor method and then also the difference of squares method. So go ahead and check out the assignment that's up for you on Edge Elastic. Let me know if you've got any questions, and then make it a great day or not. The choice is yours.